Cost optimization in 5 perspectives with respect to the AWS cloud. So we first start with a question. When you did go to bed last night, what did you do with the temperature in the house, or what did you do with the lamps, the electricity, the lights, sorry. I guess you switched off the lights and the temperature was reduced, maybe automatically, maybe manually, but at least you were doing something with, well, be sure that you were as efficient as possible when it comes to energy consumption. But how does this relate to your company and to cloud cost within your company? We often see happening this. So a company signs up for a business case to shift to the cloud platform, to AWS, hopefully. Somewhere in most of the situations, the business case financially is positive, and there are also other benefits. But the common reality we often experience afterward is that the costs are not going down as expected, but even worse, can become higher. And it's not strange that that happens, because cloud cost management, of cloud financial management, is a very, very complex thing and very challenging. We can state that 1/3 of the cloud cost in general are wasted. And well, here you see in the slide some quotes from research like Gartner. And to highlight one, for example, the reservations, 47% of the Amazon users is making use of AWS reserved instances. I think that's very very small, and even a worse amount when we look in our local Benelux market. And from our perspective, reservations is typically such a thing like a quick win. And it's not strange that this is happening, because cloud spend traditionally was managed completely different. Traditionally, IT spend was managed via procurement processes, via yearly budgets, via spend boards. And today, it's a completely new game. It's driven by the code of the developer, the code of the engineer that's pushed towards the platform. And also, on an average, each AWS servers on the average has around 4 different cost drivers, which means multiply it by the 200 plus AWS services that are available nowadays. It means that there is a lot to be aware of when you start using the platform. So sure.
Yeah. So as Jeroen was saying, guys, the cloud financial management domain or discipline is something new, and that on its own make it really hard. But I just want to really take one step back here and show to you what we see as cloud financial management, because it's much bigger. And although the topic of today's talk is cloud cost optimization, and I promise you we're going to dive deep into that, please understand that this is one small part, important but small part within a bigger discipline. So it goes from strategy to FinOps, which will be the operation side of the cloud financial management, and cloud cost optimization is in there, right? So when we have that as an ongoing process, this is the ideal situation, right? We have established some baselines, and then we have visibility towards what is being consumed, and this visibility is in this diagram awareness, and that awareness will drive the accountability. And then once people feel accountable and they see something is not as optimal, as efficient as it could be, they will change things, and they will keep track of that. So that will demand awareness. It never stops, and it really is helpful. And this is a learning from our experience in this subject, that if you have some values, some principles to attach to that, this will make really people more engaged, right? To not make this just about money. It's about the challenging, the efficiency, but it's also give them some perspective about it. Yeah. So without further ado, let's jump into the cloud cost optimization part. So Jeroen, back to you.
Yes. So when we talk about cloud cost optimization, we usually approach it from 5 perspectives. And the 5 perspectives are now visible in the screen. So the first perspective is service right sizing. It's basically about if you are using sufficient, but also not more than you really need, right-sized capacity. The second perspective, service characteristics, is about, am I using the AWS service according to the latest AWS efficiency or cost efficiency best practices? And do you understand the cost drivers of each service? Then the third perspective is consumption model, which is about reservations, savings plans, and basically everything around how you consume and purchase the service. Then the fourth perspective is service architecture. And this is about the question if you're really using the most sufficient and most efficient service for your use case. And the last pattern is about doing analysis, slicing and dicing on data, on cost data, to identify behavior that that is, for example, a trend line that you can use to optimize. So, Michel, can you highlight each perspective?
Sure. So when we talk about the service right sizing, guys, and quick disclaimer here, we're bringing here a real life situations and cases, that we have faced during the years, and each one of the perspectives will bring some considerations. Because of the time constraints, we cannot go through each one of them, so I will try to highlight a few. But be aware this material will be shared after the event. So when we talk about service right sizing, we really want to highlight that it's not just picking the right size of an instance, right? It's about being aware of elasticity. The elasticity is one of the principles of cloud, and if you don't leverage that, if you always keep everything on, then you're not leveraging. So it's consuming only what you need. So this is about elasticity. And when you talk about the possibilities of consumption in cloud, if you don't stop using things and you forget them, this generates zombie assets. So be aware of those things. So the calculations here is about right sizing, but it's also about zombie assets and elasticity. So there was the situation when we had a migration to the cloud, and the customer had this a workload that would match an M5 extra large. So this would be the yearly cost for one M5 extra large, 4 vCPUs and 16 gigabits of RAM. But after digging deep, we realized that the workload could actually run on an M5 large, so it was over provisioned already in the data center. And then we said, okay, let's use this, which would bring half of the amount in savings. And then we said, why not try something that is similar in terms of characteristics? So we said, let's test it. And yes, a T3 burstable instance would do the trick. So it further reduced the cost of the workload in the cloud. And that by itself, in 10 instances, was able to bring almost $12,000 in savings on a year. And that just on the side, yeah? And a few other things to consider are the elimination of zombie assets. But as I said, don't stick only to EC2. This can be also applied to RDS and other services. And also, when there is a lot of right sizing opportunities, especially after migrations, yeah, on-prem to AWS. So going on, service characteristics. So this has several nuances, but do understand what you pay for. If you pay for compute, and understand it's not only about EC2. You can use Lambdas, you can use Fargates, you can use other things. So, and each service will charge you for a different thing. So whereas you can use EC2 and you don't have the know-how and the skill to migrate and refactor to use Lambdas, okay, but just using a newer instance generation can save you money. It's not a lot, but in the long run, every small savings will count. And also avoid traps. Okay, I need to test this, and don't deploy really highly available databases, for instance, on test environments, if you don't really need to test that specifically because it's going to cost you double the price. And mind storage, so you always come out with a GP2, but maybe you can use a different type of storage for your instances, and that will make a lot cheaper, especially if you go really for provision IOPS when you don't need that too much. Okay, mind as well region differences. If you are trapped, let's say, within Europe because of GDPR, but you can you don't need have that much of a constraint with latency, for instance. You could choose a different cheaper region. So in this case, we're showing that the same instance just varies 7% in terms of pricing between Ireland and France. Okay, so do keep this in mind. So other things to consider are here. I would like to call your attention here for the DynamoDB, to be aware of indexes, special global indexes. Okay, so moving on, consumption model. So we usually stick to the commitment-based consumption model. So RIs, reservations, savings plans, and spot. Spot is not a commitment-based. So the example, the calculation is about that, but there are other things to consider. So first, if you look into this example, it's just about reserving without any upfront, yeah, an M5 extra large instance in the Frankfurt region. So it will give you almost 37%. And the story here is that the customer moved applications and they were using this, but they said we suggest let's do reservations around this. There is no need for an investment if you don't have the budget right now to do any upfront investment, but let's do some commitment because you say you need it. It's on the production environment, so this is not going anywhere. And the customer said, look, but there is a chance we don't need all of it. Maybe we will use only 85% of that. Yeah, but if you do the math, you're still going to save money. Yeah, so sometimes it's good to make a commitment, even if you reaching break even is easy. Yeah, just a simple math can really clear out the field for you to make a decision. Other things to consider would be the spot. If you have the chance, if your application workload is fault tolerant, go for spot. Up to 90% savings. Nothing else will bring that much savings for you. And workspaces, yeah. So if you have the need for workspaces nowadays, this is becoming really common, and user computing through the cloud. Really, if you, for standard and performance, the most used ones, break even is 78 hours. Between the difference of the rate of the hourly subscription to the monthly subscription, it's good. If you use more than 78 hours, go for the monthly one, because then you're already breaking even. Yeah, so please mind your consumption model. To highlight further this, I made this very simple table, yeah, where you can apply these consumption models to different services. And be aware, we stick a lot to EC2, but there are considerable savings to be done in this area here. Just one customer I found that has over 70 accounts. Within 4 accounts, I was able to find between RDS and Redshift over 150,000 in savings with reservations with no upfront. So the one that's been the least savings, I was able to find over 150,000 in optimization. So don't dismiss it. Yeah, service architecture. So this is really broad, and it really depends on each one of on each service that you want to use. But the story here is about this customer that we analyze. Okay, to deploy your application on Kubernetes on EC2, this is what's going to cost. We need this T3 large because it's the one that we really the least we can use, the smaller instance, and then we can have that. But if we use EKS on Fargate, that will cost about $500 less. But if we go to ECS on Fargate, that will bring it down to $400 a year. So there is a lot of savings if you can really think up front and take into account the cost on the architectural and design phase. This is really can bring significant savings, yeah? And people worry always about availability, reliability, and if it's going to be secure. Do think about cost as well, because as you see, this can make the difference between go, no go, yeah? And also about operational systems. So everything that brings a license is going to be considerably more expensive. So if you can build your application and your environments around licenseless, let's say, OSs. Yeah? So other things to consider here, it's really a lot, because it really depends on the server that you're going to use, on the service that you're really aiming for. But please give it a read afterwards. Yeah, we really don't have the time, unfortunately, to go through each one of these. And last but not least, service patterns. So what we really suggest is for people to start measuring things, yeah, and build a baseline. It doesn't have to be something very complex. It's just so you have an idea how much do you pay, and then start tracking. If something goes strange, you will pick it up, and then you can do something. So 2 stories here, very quick. So there was this one customer that has this app making GET requests on S3, and then we realized that on the bill, not even on the app, that the ratio between storage costs and requests on S3 was really big. So we said, what's going on here? And then after analyzing, we saw that the application was pulling every 1 minute. And then we said, okay, can we do something about it? Can we actually change this to 5 minutes? And yeah, it was completely acceptable. And then we got really to reduce this by 5, the number, the cost of requests. And about the AMI, autoscaling was really going scaling up and scaling, and it was about the web servers of this company. And what they realized is that the number of visitors to the website never changed. So after some investigation, we realized there was the AMI was hacked, and that there were crypto miners in the AMI. So do establish a baseline, start measuring. It's really important. Dr. Werner just said that, said so in his talk. So it's really important to keep an eye on things, and it will make your life easier finding those anomalies. So the last slide on my side is just to see that the combination of things, those things are not mutually exclusive, right? So you can do right sizing, and then you can define that after you right size, okay, I'm better off running this workload on this region here. And after that, if you know that this is a production workload that is not going anywhere, do make a commitment. And then just by doing this, you can really reduce. On this example, it's 75% reduction on the cost of that. So I'm really honored to be here and speaking to you guys. So I hope that you can pick something that I said here, even one thing, even if it's not exactly the thing, but if it inspires you, I think I have shared with the community, and this is the point today. So please feel free to leave questions, and back to you, Jeroen.
Thank you, Michel. So some takeaways. I think the key thing that we want to bring over is the 5 perspectives. So look at your cloud environment from cost efficiency perspective from those 5 perspectives. So am I using just enough that I need? Service right sizing. Do I understand the cost drivers, and am I using the service according to the latest efficiency best practices, the characteristics? The consumption model, am I doing reservation, savings plans, or do I have the right consumption type, like hourly versus monthly? Service architecture, again, do I have the most suitable service applied for my use case? And the last one, doing an analysis, benchmarking, and trend detection. Before we go to the questions, well, from Oblivion Cloud Control, we think cost management is essential, and we want to help everyone with this. And to get started with cost optimization, we launched conversation starters. It's actually a set of 52 cards in a box, and each card contains questions and context and an indication how much you potentially can save and how much effort it would take to implement it or to consider it. So if you are interested in a free package, conversation starters, reach out to the sponsor page on the Grip event platform, or send an email to Michel or me, and we will make sure you will get one. We have a few minutes left for questions. You can drop your questions in the live chat on the event platform. There's one question that I will, as the host of this track, will ask to Michel. There's someone asking about a bit more detail about difference between reserved instances and savings plans. So basically, what's your advice, Michel, to apply for what in which situation?
Okay, so there are a few, but I'll try to summarize this. Reserved instances are more specific. Okay, so savings plans have two types. You have the EC2 type, and you have that's only applicable to EC2, and then you have the compute type, which is also applicable to Lambda and Fargate. But that is really flexible, and you make just a monetary commitment that is going to spend a specific amount every hour, and this is going to be applied. AWS will try to find the best discount that within all the users you had within that 1 hour, they will try to apply that. But then you don't have a lot to do. It might be that it's going to be applied on something with a Windows license or a Red Hat license, and it's not going to bring you a lot of savings. On the reservation side, you really need to you still have a lot of options, but not that many. So, which means you give the AWS a really good idea what is going to be the capacity you need. And they provision that to you. Therefore, they know upfront they will give you a lot of a better discount on this. Yeah. So what really varies here is about if you're going to make an upfront investment on it or not. And by our experience, doing a partial upfront is always really, really good. It's better than an all upfront. Brings you a little bit more savings, but not. I would say it doesn't cover the investment. And no upfront will. If you don't have the budget, go for it. But otherwise, the partial upfront will bring you significantly higher savings. Yeah. So. Reservations is more specific. Savings plans is more flexible. Yeah, but do one of them.
Thank you, Michel.
Don't leave it.
Thank you for answering. So with this question, because of the time, we will end up our talk about 5 perspectives on cost optimization after your migration to AWS. As a speaker and as a host, I would like to thank you for joining us for this track. We will start the commercials, and then after that we will continue with our second speaker for this track. Thank you, Michel, and see you.
Thank you everyone.